This conference will now be recorded.
Okay, thank you, Elena. Good afternoon, at least in Massachusetts. My name is Henry Barbaro, and for many years, I was the supervisor of the stormwater program for the Massachusetts Department of Transportation, also known as MassDOT. As Elena was saying, I retired about a year ago, but I'm glad to talk with you today about my experiences with the stochastic, empirical loading and dilution model, also known as SELDM. This model was developed by USGS and can be used to accurately estimate a DOT's contaminant loading to a receiving water. First, let me mention my life before SELDM. Back in 2006, the Conservation Law Foundation filed a lawsuit against MassDOT in federal court. The plaintiff's subject matter expert was a professor at Northeastern University, and he was hired to document water quality problems at 3 sites that specifically for heavy metals, lead, copper, and zinc, which these problems presumably being caused by MassDOT. During the court testimonies, I was surprised to learn that the professor never had been to the 3 sites in question. He used only a desktop analysis with NERP data and a basic uncalibrated water quality model. Unfortunately, the number crunching swayed the judge, and MassDOT had no compelling way to refute CLF's claims. So we were forced to install a series of BMPs at these 3 sites at a total cost of around $2 million. With minimal water quality benefits which will never be measured or observed, it was clear that this BMP retrofit work was not a good use of tax dollars. The court order also led to the, on the bright side, I guess, the court order also led to the establishment of MassDOT's Impaired Waters program, which involved assessing our stormwater discharges to hundreds of impaired water body segments throughout the state. I'll describe this program, the Impaired Waters program, in a couple of minutes. In 2012, the Massachusetts Department of Environmental Protection identified 288 river, lake, and coastal assessment units that had TMDLs for 1 or more pollutants, and another 720 assessment units which were identified as needing TMDLs. This map shows these water body classifications in Massachusetts. Statewide, the process for assessing potential highway impacts on these water bodies would be a cumbersome and very expensive modeling process. MassDOT maintains about 16,000 lane miles of roadway and more than 8,000 bridges and culverts. And these are depicted in red. I'm sorry, the red and the blue on the map kind of intersect all these highways, and as well as what waters are impaired and are in need or have a TMDL. With so many discharges to so many water bodies, MassDOT needed to develop a robust, defensible, and cost-effective way to assess our discharges to different water bodies. To execute the Impaired Waters program, MassDOT has a 5-step assessment process for impaired waters. The first step is to identify impaired waters to which MassDOT's urbanized roadways may potentially discharge stormwater. Second, conduct desktop reviews and or site surveys of potential runoff from MassDOT highways. Third, define the stormwater contributions to impaired waters, which includes calculate loading for MassDOT stormwater, estimate other sources of nutrient loading, and calculate the MassDOT percentage of total loads to the impaired waters. The fourth step considers control measures for pollutants of concern listed in TMDL reports that do not contain waste load allocations. So steps 3 and 4 are really where SELDM model comes in. And lastly, we select, design, and implement stormwater BMPs. Oops. So not only can SELDM be used to calculate contaminant loads from the highway and from other land uses that contribute to the impairments, SELDM also can be used to calculate how BMPs could potentially reduce the volume and concentration of these discharge pollutants. As a basis for developing SELDM, MassDOT conducted a series of highway runoff studies during 2002 to 2010 in cooperation with the USGS to define runoff quality. After MassDOT lost the lawsuit, we continued to face regulatory pressure about MassDOT's pollutant loading to receiving waters, especially those that were impaired. This map shows the location of the 10 highway runoff study sites, the big yellow circles. The study, which cost about $850,000, was designed to characterize the quality and quantity of runoff at sites with different traffic volumes, different surrounding land use intensities, and different ecoregions. The SELDM model, fully calibrated for Massachusetts, was published in 2013. The data generated from these study sites were entered into the Federal Highway Runoff Database, which allows for a standard method to calculate runoff quality statistics. About 10 years ago, Massachusetts datasets represented 14% of highway sites and 29% of event mean concentrations throughout the country, with only Caltrans having more sites and data. Today, though, I believe that North Carolina has taken the #2 spot, and MassDOT has the 3rd largest data set. Over the years, the Massachusetts Estuaries Project had been evaluating 89 coastal embayments for nitrogen TMDLs. It turned out that SELDM was ideal for this work. This map is from the Massachusetts Estuaries Project and shows the location of these embayments in southeastern Massachusetts, Cape Cod, and the islands. For many basins, the contributing areas are based on regional groundwater models. Developing detailed rainfall runoff models for each watershed would have been cost prohibitive. So MassDOT used SELDM to develop an average annual loading rate per acre of pavement and to calculate loads by using the area of state-owned roads in each contributing area. For a simple example, the West Falmouth Bay is located within the town of Falmouth near the southwest corner of Cape Cod, where the arrow is. West Falmouth Bay is subject to a TMDL because the condition of the bay has been deteriorating rapidly over the past decade as a result of nutrient overloading. The main concern was a plume of treated wastewater effluent from the town's wastewater treatment and infiltration facility. This map shows the 2 MassDOT roadways superimposed on the groundwater flow cells contributing to West Falmouth Bay, which is a small 200-acre bay with a 1,900-acre contributing area. On this map, the delineated areas are the groundwater contributing areas to different segments of the bay or the surface water tributaries. About 17 acres, which is less than 1% of the watershed, are MassDOT roads, including about 1.2 miles of State Route 28 and about 1.6 miles of State Route 28A. Using the MassDOT concentrations with the SELDM model, the hydrology of the SELDM model reduced the calculated values of concentration and flow of runoff from these 2 MassDOT roadways. The Cape Cod Commission estimated that MassDOT roadways would contribute about 13.6 pounds per acre per year, while the SELDM analysis estimated the nitrogen loading to be only about 6.2 pounds per acre per year without any BMP treatment. So that's less than half. This loading rate was used with GIS to calculate the Mass DOT total nitrogen loads within this and other drainage areas on Cape Cod. The combination of lower flows and lower concentrations reduced annual loads by more than half. The SELDM analysis indicated that MassDOT's contribution was only about 4.4% of the impervious stormwater load to the bay and less than 0.25% of the total nitrogen load to the bay, which was well within the margin of error of the loading calculations. Therefore, construction and maintenance of new highway BMPs for reducing nitrogen to the bay was not considered to be cost effective. It turns out that the major man-made source of nitrogen was a local wastewater treatment plant, but also septic system discharges and residential lawn fertilizers. Another important role for SELDM relates to phosphorus. Years ago, MassDOT started to estimate contaminant loading using complex long-term simulation models, such as the EPA's Stormwater Management Model, or otherwise known as SWIM. SWIM had to be calibrated by using many variables from a long period of hydrologic data. In 2012, the SWIM model predicted our total phosphorus loading to be 2.14 pounds per acre of impervious surface area per year. This loading rate was higher than the EPA's calculation using the simple method to estimate annual loads, which were about 1.3 pounds per acre of impervious surface per year. To reconcile this discrepancy, MassDOT worked with the SELDM model, which calculated the long-term average to be even lower at 0.98 pounds per acre of impervious surface area per year. So, based on the model loading rates and the average NCHRP treatment cost, this was a NCHRP report done a few years ago, of about estimating it at $5,500 per pound of phosphorus removed. And by substituting the initial SWIM calibration with the SELDM estimate, reduced the theoretical treatment cost by about $9,200 per lane mile. Since MassDOT owns 16,000 lane miles, there are huge financial consequences for miscalibrating phosphorus loading, well into the tens of millions of dollars. So I am going to end my talk with a case study. In 2022, the Lake Thompson Association filed a complaint against MassDOT. Their complaint was that I-90, also known as the Mass Turnpike, was a major contributor of phosphorus to Lake Thompson. And they wanted at least one major BMP installed. Using stream stats for basin properties, the highway runoff database also was used for highway concentrations, both with and without winter sanding. The BMP statistical estimator for developed area concentrations and SELDM for runoff yields. So all those data sources were used. By SELDM determining phosphorus yields, it became obvious that I-90 was an insignificant contributor, even less than atmospheric deposition, and that with so little water quality improvement to gain, the tax dollar expense of building a BMP could not be justified. For this small watershed, the most significant phosphorus contributors were developed areas such as houses, driveways, and yards, as well as local roads. So again, here's some math. BMP construction, let's say at about $60,000 to $1 million for this 6-acre stretch of highway, and does not include forever maintenance costs. To reduce watershed loading by only 2.2 pounds per year, which is only 1.8% of the total phosphorus loading to the lake. So looking at the big picture, literally, this one road, the Mass Turnpike I-90, is 138 miles long and 88 feet wide, average, for a total of 1,472 acres of pavement. That's over $94 million in construction costs for your average BMP, priced at $64,000 per acre. In 2023, MassDOT's total budget was $752 million. Again, over $94 million to install BMPs for only one road in Massachusetts. So SELDM is an important tool for the cost-effective management of Mass DOT's stormwater. So when I give a talk, I like to end with, and I have a little bonus topic at the end of this, but I want to end with what I call take-home lessons. So the first one is that SELDM provides a rapid and defensible contaminant loading estimates because of prior data collection efforts and methodology approved by USGS, Federal Highway, and EPA. And as I mentioned at the beginning of the talk, it did require some data collection, stormwater data, for calibrating the model for Massachusetts to the tune of $850,000 back then. Probably be closer to $1 million now. Secondly, because SELDM can generate water quality estimates statewide, using the model prevents the need to spend tax dollars for site-specific stormwater monitoring and treatment. So just as one example, that Lake Thompson site, you know, the Watershed Association wanted us to go out there. Not only, well, they wanted MassDOT to install BMPs, but before that, they wanted the water quality need to be demonstrated via, you know, monitoring studies and water quality sampling and so forth. So it was going to be a big effort, and this is a kind of something that comes up on a regular basis where, you know, a citizen group or environmental group wants MassDOT to study and to mitigate their particular water body of concern. So it was good to use SELDM to prevent that enormous hassle and cost. And the third take-home lesson is that given the massive number of DOT discharges, stormwater discharges, SELDM serves as an important tool for cost-effective decision-making statewide. Also, without such a reliable and defensible tool, MassDOT would be vulnerable to lawsuits and unwarranted enforcement actions. So that's the body of my talk, and like I said, I want to just hit on it one last point. So thank you for your attentions so far. But as I was slowly, methodically retiring, Greg Granado pointed out something that sort of some findings from a SELDM analysis he had done, and I don't really I'm not really ready to, it's kind of complicated, kind of nerdish, and I'm not totally prepared to describe it, but that when you're in a degraded watershed, the benefit of installing BMPs as you go downstream becomes less and less because the water coming in, so to speak, or the water that's being discharged to has a certain concentration of, let's say, phosphorus, and the even if you have relatively clean water going to it, you're still not going to bring down that concentration of that background concentration of phosphorus. So he had the idea of, rather than having DOTs pour money into constructing BMPs and then forever in perpetuity inspecting them and cleaning them out, that it was more cost effective and a more of a win-win all around to purchase and acquire, in the spirit of source control, these sort of upstream headwater parcels. And it's sort of in the spirit of source control, rather than try to do something about water quality, downstream. Now this, I'd like to explore this, or I'm hoping that MassDOT, keep forgetting I'm retired. I'm hoping that MassDOT and USGS further explore the potential for this, because I think it would be great. I think it would be great for DOTs. They would possibly have more effective benefit to water quality in a watershed, and they wouldn't be saddled with, certainly this long, forever, in perpetuity inspection and maintenance, and it would improve the health of the watershed overall. So I guess that I'll end it there, and I appreciate everyone's attention. And that was about a half hour or maybe less. And so I think we can open it up to questions.